Hello everyone. I'm really sorry for what happened today earlier in our demo. It was very unfortunate, and I'm sorry. Things like this happens very infrequently, and it was really unfortunate. So please accept our apology, and I'm going to show a demo in this video that is pertaining to the last part of the charts that I was reviewing that explains how we can create overlay networks using VxLAN tunneling and OBS. So basically, I'm going to review an important concept that we were talking about. VxLANs are supposed to help us in creating the overlay network on top of the underlay network technology that we are using. And for this purpose, we are going to use the OVSs. So OVS supports the VxLAN tunneling, but as you remember, we were discussing that the OVS, the VxLAN is actually adding a header to the frame, to the Ethernet frame, but encapsulates the whole into a UDP segment. Okay, so basically, it's considered to be an application layer protocol that uses UDP, and because of that, it allows you to use more VXLAN IDs in compare. And there are other information such as the outer IP and outer MAC addresses that are being added to the header of the VXLAN. So OVSs support the VXLAN encapsulation, but the type of connection that they create using OBS is unidirectional. That basically means if you need to have a bidirectional communication between two OBS, you need to create one connection from each of them to the other one. So that basically allows you to have a bidirectional communication or connectivity. So this is one of the important things that we need to do, and that also needs us to do some extra work when we create the VxLANs. Okay. So this was the charts that I was explaining during the demo earlier today. The exercise we're going to do with each other is actually creating an overlay network on top of two hosts, basically on top of the underlay network using two hosts, which for them we need to create two VMs. Each of these hosts will need an instance of the OBS, and when we run the instance of the OBS, we need to create a VXLAN interface that is connecting the OBS to the ETH0. ETH0, or the attachment of the hosts to the underlay network, is already set up, so we're not going to change anything about that. But rather, we create the VXLAN interfaces, and these two VXLAN interfaces connect the OBS into the Ethernet 0 or ETH0 of the VM that we create. And we also need to create internal interfaces to the OBS. These internal interfaces are basically attachment of our overlay network to the OBS. So the traffic going through the internal interface will go through the OBS to the VXLAN interfaces and can pass through the underlay network to the next host. Because of that, the IP addresses we assign to the internal interfaces could be different from whatever IP address we use on the underlay network. And also, basically, to create the VXLAN interfaces, we need to assign the other host IP address to the interface we create to allow them to create the unidirectional sessions. So basically, we create two unidirectional sessions that completes the bidirectional connectivity we need. So let's jump into what we need to do. The very first thing is we said uh, VXLANs are going to be encapsulated. VXLAN header is going to be encapsulated along with the Ethernet frame into UDP packets. So basically, we need to add a security rule into our security groups that allows us to basically handle this type of traffic. Okay, as you recall, I mentioned every single port that you need to use must be opened on the security group that is used on your VM. So basically, we were using the security group name default, and I need to add this rule to this security group. So just to make sure everyone follows the steps the way that it has to be, If you still if you did not use the source savvy, you need to source your username. In this case, I am using NetSoft 41, and then the tenant ID or the tenant name I'm using is workshop 5, and then I am running my VMs in the core. So uh, the password is the same as username unless you change it. Um, Sorry, one more time. Okay, so right now I sourced my username in the tenant and region that I need. Now, if I do a novel list, I should not see any resources because I deleted them. So let's create the resources we need using Savvy run server. And then we need to provide the flavor we are going to use. Let's use the same M1 small, but for the image, we need to use EC1508 overlay. That's what we need to use. Oh, sorry, before that, as I mentioned, we need to add the security group. We can do that later on after we create the VM, but just following the steps I mentioned, you can use Nova sec group dash add dash rule and use the name of the security group you are going to add a rule in, which is default, and the type and the protocol type you're going to open port from is UDP, and then we assign 4789 for the ingress, 4789 for the egress. This port number UDP 4789 is the port number used by VxLAN, so that's it's a standard form port number, and then we need to define also the network that this security rule is going to be valid in. Basically 10.0.0.0 /8 is the savvy testbed network. So whatever traffic we transmit, it can transmit across all the savvy testbed. So we do that, and we see the results. So the security group is added. Now the next step, we can basically do a Nova list again. So there is no VM, obviously. We do now this time we do Savvy. We use the Savvy APIs to create our servers, our VMs. We use M1 small. We use the ECE 1508-overlay image because it comes with the OBS. And then we have the security group and the keys that we need to provide. So let's provide the name of the key. It was, for me, it was NetSoft 41 key. And then the security group is default. And let's also provide a name for our VMs. So in this case, I'm creating VxLAN VM1. So let's run this script, and so basically it's going to create a VM. In meanwhile, this VM is being created. I have another um, session open. So I need to source again, because when you source, it pertains to the current session you have. So if you have two sessions open, you need to source again. And I am sourcing again my username on workshop 5 and core, and same username. So here, and so the steps that we did on the first in the first um, window, we do not need to go in every steps that we did here in the second one. Only we need to create the VM here. All the things, all others have been applied to the user that you're using. So we use savvy-run-server, and this time we use the same M1 small and also ECE 1508 overlay. And basically the next step is my key, which is NetSoft 41 key, and the security group is default. and the name is VxLAN-VM2. So we are creating this, and this is going to be created, hopefully. You can see from the output of this one that the first one is already being created. Let's do a normal list to see the VMs. So both VMs are running. I am going to do a ping test on both to make sure everything is fine. Uh, so the first VM is reachable. The second VM is 9. That's reachable too. So basically we are good to go. So in the next step, we need to run an instance of the OVS in each of the VMs we created. So we need to uh, we hold this to reach to the IP addresses, but we basically need to SSH to the VMs. You can use Ubuntu as the username and SSH to your VMs, because right now we are in the Savvy Client 1 machine, so we should be able to reach to these VMs quickly. And also here we can do SSH Ubuntu, let's say 10, 12, 125, and 9. And so let's SSH to them. So when you SSH, you can see that this is my VM1, this is my VM, this is my VM2. So in the first VM, I need to create an instance of the OVS. So this is going to be a command that we provided an example here. You can use the same. So OVS dash VCCTL, which is the OVS command line interface that connects you to the backend APIs you're using. We use the may exist to avoid conflict if there is one running right now, and then we need to assign a name for that, and you use the add bridge to create that. So let's name that my bridge the same as the charts. So that's basically created. You need to do the same in the second VM as well. Yes, and then you may exist, and also you need to do add bridge, and let's name it my bridge here as well. It's not a problem because they are in two separate uh, VMs, so they do not conflict each other. Okay. So after we create the OVSs, in both machines, we need to create an internal interface. The internal interface we create is basically going to serve, if you remember, for the internal traffic going on the overlay network. So my first approach after I create an instance of the OVS is I'm going to create the internal interfaces on both machines, but I do not assign IP address to them until I create the VXLAN interfaces. But for now, I'm just going to create that interface. Okay. So for this one, you need to do sudo OVS. Maybe I can copy from here. So let's see. Okay, so uh, we need to use dash exist. Oh, yeah. So, and then we use the same obvious name, and we use my int. This is going to be the name for the internal interface that I'm going to use. So that's my internal interface. And then we set the interface as, again, we use the name again. So you need to mention the name of your interface twice. Once you declare it to be part of the OVS, the second time you set that as the interface, and the type is internal. So if I run this again, so I already created that. So let's run this here as well. And so that's my int here too. So whatever I do on the first VM, I am repeating that on the second VM. So now both first and the second VM have actually one interface of type internal. In the next step, we need to create the VxLAN interface that we are going to use. This is going to be the VxLAN interface that I showed here in the image. So right now we created both interfaces on top, host 1 and host 2. Now we need to create the VxLAN interface in the bottom, okay, that connects us to the underlay network. Let's see if we can use that. Okay, so there are two important things about creating the VxLAN interface. If you remember, I mentioned you need to basically use the IP address of the other VM to create your um, VXLAN interfaces. So to know what is the name, what is the IP address of the other one, we can have another session, and in that session, hopefully it connects. I can connect with the different session, for instance. This machine. Okay, so let's source to savvy-n and use NetSoft 41 as the username, again on workshop 5 and core, and let's use NetSoft 41 as the password. So do Nova list, you get the VM's IP addresses. So that's for VM2, and here I am on VM1, so I need to basically change that to 10, 12, 125, 9. That's the IP address of the second VM. And so if you take a look, the same structure as we used before for the internal interface, except this one is going to be the VXLAN 1, which is going to be the name for the interface I'm creating, and that's the interface VXLAN 1. The type is the VXLAN, and then there are options we provide. One is the remote IP address. The other one is the key, which I put 1024. That's the VXLAN ID that allows the two VM that have this particular ID to share the overlay network traffic with each other, so they can see each other in the overlay network. So whatever key number we use here, we have to use it on the second machine as well, on the second VM as well. So let's create that one, and then basically need to repeat the same thing here. We do not change the key. We'll let the key to be the same, but we need to change the IP address to the first one. And here the IP address to the first one is 10, 12, 125, and what was the first IP address is 25. So because this is the second VM, so it needs to use the IP address of the first one. Everything else can remain the same. Okay, we use the same type and we name it as the same. And also the key must be unique to both. Okay, so let's create that. So now we created the VxLAN, and so basically, if we by repeating that in the second VM, we just created a bidirectional communication here. Each of them is a unidirectional, both create the bidirectional. So we can also check to see if our interfaces have been created. Let's do a test here using OBS, OpenFlow, CTL, show my bridge was the name of the instance we created. So you see I have the my int as an interface, which is a type of internal. Then I have the VxLAN, which is also created, and this is also the instance that I created. If I repeat the same thing here using OBS show command on my bridge, you see the same thing is happening here. Okay. So in the next step is I need to assign an IP address to the internal interfaces that I create so they can actually start communicating with each other. We can do that using the ifconfig command in our VMs. So basically, I use ifconfig, and then I say the interface name is my int because this interface is already created, so your ifconfig can recognize that. And then I need to provide an IP address that this interface needs to consider for as an attachment to this endpoint. So in our example, let's use 10, 20, 30, 100 subnet 24, and let's set the MTU to 450, and we use up to allow ifconfig to boot up the interface the moment it's assigning the IP address. MTU is the maximum transfer unit, and 1450 is 1450 bytes, and technically we set that MTU to 1450. That's the standard for the MTU in on the internet. So basically that MTU prevents us to do a lot of fragmentation. So that's why we ask you to do that. In your lab, please use that 1450, which we used here in the demo. So I set that here, and if I do if config myself here, I should be able to see my interfaces. So you see my int is here and the IP address is assigned here, 1020, 30, 100, and then the MTU is 1450 as we requested, right? So we need to repeat the same thing here and assign an IP address so they can see each other. Okay, so that's if config, the name stays the same, but let's do 10, 20, 30, and this time 200, and subnet 24. Let's set the MTU to 1450 bytes and use up the interface right away. And if I run if config, you should be able to see this interface with the IP address we provided on the second VM and the MTU of 1450. So now basically we created the overlay, and the underlay network has a different IP address. So basically this is the IP address we have on the underlay network. That's 10.12.125.25. And the other machine has a different IP address, which is uh, this one, 10, 12, 125, and 9. But we also created an overlay network through our internal interfaces, and that's a different IP address. And I'm expecting to ping the remote machine by using my overlay network IP address, and it should work. So let's ping 10, 20, 30, and 200 because that's the second VM we are going to ping. So you see, uh, we can ping that machine. And also, I want to ping 10, 20, 30, 100, and I should be able to ping that machine as well. So this traffic is actually going into the overlay network using the overlay IP addresses that we use. But the IP addresses in the underlay is different. So if I use ping um, 10, what was the IP address we were using? 10, 10, 12, 125, 25, I still should be able to ping the second VM. But remember, this IP address that I'm using, and I'm using that to ping, is from the underlay network. So that's a different one. And the two may traverse different links in the underlay network. But basically, this is how the overlay network works. So you can now have a private channel communicating between the two VMs using the OVSs that we deployed into each host and the VxLANs that we used to create that overlay network. Okay, so that's the strategy we used. We just basically created these OVSs and create two different internal interfaces, and now we are able to transmit that traffic. So, and that concludes my discussion about the overlay networks. During the lab, what we expect you to do, we will shortly after this session, we will shortly post the lab handout, In the lab handout, we ask you to repeat the same thing. Basically, you are going to first use Python the same way as I did earlier this morning to manage the VM creations and life cycles of the VMs. And you need the SSH library to be able to programmatically SSH into your VMs, and you need to create the same overlay network. There is a script being provided to you when you use the image we ask you in the lab handout. You need to complete that a script which is written in Python. You need to complete 6 functions inside that skeleton code that we provide to you so that you can create an overlay network. And that overlay network has a boot VM that's similar to what we did today, that we created VMs. So you can create a VM, and so you have to complete this one. Set overlay interfaces is basically what we did today right now. We just created an overlay network, so you should be able to do that easily. And then you can connect nodes that's basically assigning IP addresses to your interfaces. And then deploy overlay, we want this to take control of deploying this programmatically. So basically you can avoid all of these configurations, manual configurations. It should be orchestrated automatically. And then there is a function that you need to complete that allows you to see all the overlays you created. And you should be able to clean your resources, the resources that you created as always. So use that to complete. That's the same as when we deleted our VMs there. And then to provide the topology that you need to create your um, uh, code, we use a file topology that this is explaining the file topology. For instance, in the example that we followed today, we had this given topology that there was switch 1 and switch 2. Each of them had host 1 and host 2, and then they are connected to each other. So to show that into the topology file, you need to define a topology, and then inside the topology you have 2 switches. So basically you define your topology by the switches that connect to each other, and then you define the set of elements that connect to each switch. So H1, and the IP address we provide here is the IP address of the overlay network. Okay, and then the topology in the second one, the second switch connects to the switch 1, and then it also has a host 2 with the IP address that is supposed to be assigned in the overlay network. That's the internal interface. And so basically you can use that to take advantage and leverage that to deploy your overlay network. Um, so you can take advantage of different Python resources. I'm going to include the set of Python commands that I used earlier this morning to create my VMs and everything. So that's going to be an appendix in your lab, but further instructions you can find on the references we provide here, and maybe other references that you find. So basically, Google is always your friend, and you can ask any questions on Google, and I'm 100% sure that you will find quickly answer for them. Even if you just copy the paste the type of the problem you are facing or the error that you are facing, you will get answers. We are more than happy to respond to your questions on Piazza. Please post on Piazza, and we will be monitoring Piazza and responding to you. And so your codes will be checked against for plagiarism, and I am asking you not to do anything in terms of copying work, which I'm 100% sure none of us will do. But this was an important note that I wanted to highlight, that we will do check against the plagiarism. So the last thing to remember is, please delete all of the resources that you create after you complete the lab, to give enough space to provide enough space for others to do their labs. And thank you very much. That concludes my tutorial for the parts that we didn't complete this morning. Have a good day.